So lesson 6 is going to be much shorter than what we had yesterday. Lesson 6, we're going to review how do we solve equations that have fractions in them, not just simple fractions, but also ones that maybe have variables in them, so some rational expressions in there. Radical equations are things that have square roots in them, and we're going to review our methods for solving that. And we'll also be reviewing some systems of 3 equations. So the first one that I want us to look at today is one when we have fractions in there. In this case, variable expressions are also part of that. When we have that, we want to clear fractions, whether they're simple fractions or ones with variables. And we do that by multiplying everything by the least common multiple of all of the denominators. So for this one, the denominators are 5 and x plus 7. So we need a 5 times an x plus 7. And then we also have a 3, so we also need times a 3. So we need to multiply all 3 terms by 15 x plus 7. I am going to ask you to please not try to do too much in your heads, because I see too many mistakes year after year when you do that. So I'll write the next step either of 2 ways, and I want at least one of these next 2 lines that I'm going to write. If I take the 15x plus 7 times the first term, the 2/5. First thing I want to do is to see, well, what does the denominator cancel with? The 5 cancels with the 15. 15 over 5 is 3. The original numerator is 2, and I did not cancel the x plus 7. So I want you to either write it like that or 6x plus 7, but I want you to wait on the distributing until the next line. Then we multiply by the middle term, and the x plus 7's cancel. So that just leaves us with the 4 times 15. You may either write that or you may write it as a 60. And don't forget the last term also. And we'll see what the denominator cancels with. The 15 over the 3 will cancel to give us a 5. The original numerator is 4, and we still have the x plus 7, or you may write 20x plus 7. Then I want to see the distributing. 6x plus 42 plus 60 equals 20x plus 140. And now I'd like for you guys to finish that. When you know what x equals, type it in chat, but please wait to hit enter. And since I see quite a few heads popping up, go ahead and hit enter. Let's see what we're coming up with there. Your job was to work it and type your answer in chat so it was ready to hit enter. And looks like we're starting to reach a consensus of negative 19/7. So if I subtract this 102 from both sides, I have 138 over here on the right, and then I'll get all of the x's on the other side. So I have negative 14x, divide both sides by negative 14, and simplify. And whoops, not 138, just 38. 140 minus 102 was 38, so that gives me a negative 19 over 7. So for the most part, we did fine with that consensus. Okay, let's do a system of equations, but one that's very, very messy. So with this system of equations, I am going to begin by clearing the fractions in the top one and the decimals in the bottom one. So I need to get the least common multiple of these denominators. Least common multiple of 2 and 5 is 10. So for that equation, when I multiply a half x by 10, I have 5x plus, and then the 5 cancels with the 10. 10 over 5 is 2 times the 3y gives me a plus 6y. And then I have a negative times 10, so a negative 10 over 5 is 2 times 2 is 4. So now I have my first equation set up. For the second one, I have 2 decimal places, 1 decimal places, 2 decimal places. So I need to move all of the decimals 2 spots to eliminate all of those. So this will give me 6x. If I move this one 2, I need to put in a placeholder. So then I have minus 20y. And this one, when I move it 2 places, I have equals 104. You may either think of that as moving the decimals all the same number of places, or multiplying by 100 moves the decimal 2 places. Now I look at these, and I could do substitution, but then I'd have some really messy fractions to substitute in. So what would have been the point of clearing all of those fractions? I'm going to notice that I've got a 5x and a 6x. And so if I multiply the top by 6 and the bottom by 5, they'd both be 30. So then I'd have at least the same number, but I really want one positive and one negative. So either one, I'm going to pick the top one and multiply by a negative 6 and the bottom one by a positive 5. So I'll get plus and minus 30x that will cancel out. If I do that, I have negative 30x minus 36y equals positive 24, and 30x minus 100y equals 520. Now combining those, negative 136y is 544. And somebody help me out with the division on your calculator real fast. If I divide both sides by negative 136, what is that giving me for y? Anybody have that on your calculator yet? So it's like a 4. I think it will be a negative 4 since I had a positive and a negative. So thanks for helping me out there. We're solving a system, so that means we still need to go back and figure out what x is also. Normally, I would recommend, if it makes sense to, go back to one of your very original equations and solve that. But that's going to be kind of messy either way that I go there. So I'm going to trust that I did my work correctly, and I'm going to pick one of these two where I no longer had fractions or decimals. And I'm going to pick the top one just because it has smaller numbers. So 5x plus 6 times y is now negative 4, has to equal negative 4. 6 times 4 is a negative 24, so if I add 24 to both sides, 5x is 20, which means that x needs to be 5. No, x needs to be 4. Not paying attention to what I'm doing there. Then I need to write that as an ordered pair. X is 4, y is negative 4. So everybody kind of remembering how those work. Okay, don't see any questions or comments there. So let's talk about solving equations with square roots in them. We always want to isolate the square root. So we get square root equals. When you have more than one square root in it like this, I recommend start with isolating the messier, longer one first. So the longer one is the square root of y minus 3. And if I get it by itself, that means I have the equal sign next. Change sides, change signs, take the root y to the other side, and I now have equals 2 minus root y. Now that I have a square root isolated, I want to get rid of this square root, and I do that by squaring it, because squaring a square root makes it go away, so that I then just have y minus 3 on the left, so that's much nicer. But if I do something to one side, I have to do it to the other side, so I also need to square 2 minus root y. And here's my caution for you. That is not 2 squared minus root y squared. That is not 4 minus y. It's also not 4 plus y. What you must do, and I strongly recommend that you write it out, you need to take 2 minus root y times 2 minus root y and FOIL that. So 2 times 2 gives us 4. 2 times minus root y is minus 2 root y. Then the insides, we get another minus 2 root y. And the outsides minus minus gives us a plus. Root y gives us a regular y. The o and the I are like terms, so we have 4 minus 4 root y plus y, and that is what is equal to y minus 3. So we isolated a square root, and then we squared both sides carefully. Now we're going to combine like terms, because we always do that in algebra stuff. So if I subtract y from both sides, I no longer have any of those regular y's, so that's nice. I need to repeat this process, and this time I need to isolate the only square root that I have left, and it's now going to be just a square root of y. So I need all the root y's on one side, everything else on another. So I subtract 4 from both sides, and negative 7 equals negative 4 root y. So I'm getting closer. I only have root y terms on the right, but I need it to be just root y, so I'm going to divide both sides by negative 4, which is kind of nice because then I have a square root actually being a positive number. Continuing this, repeating the process, that includes squaring both sides again. But this time that's easier and doesn't involve foiling. If I square just the root y, I have the regular y that I want, and 7 over 4 times 7 over 4 is 49 over 16. Anybody remember what you are required to do when you solve radical equations? There's one step we still need to do. Got to check those answers. In this case, we only have one. So we need to take this 49 over 16 and make sure that it worked all the way back up here in that original equation. So I'm going to rewrite that original equation just so I can see it while I'm doing my work there. My original equation was root y minus 3 plus root y needs to be equal to 2. So if I take this 49/16 and plug it in, root 49/16 minus 3, but I'm going to write 3 with a common denominator, so minus 48/16. And then I have the square root of y is 49/16, and I'm hoping that comes out to equal 2. So square root of 1/16 will be a fourth. Square root of 49/16 is square root of 49 over square root of 16, so 7 over 4. And sure enough, 1/4 plus 7/4 is equal to 2. So I'm in good shape. It checked. Y equals 49/16 is my answer on that. And then I want to move to one last topic for the day, systems of equation. We'll do one example and then we'll get going on one of the homework ones. So take a look at this system and type into chats what strategy you'd like to use. There's more than one right way to approach this problem. So just take a look at that and see what you're thinking you would like to do. And you can go ahead and hit enter as you type in those strategies, just so we start seeing some ideas coming up. Okay, some people are suggesting isolate x. We could say x is equal to 2y, and then we could plug that in for this x and this x, and then we'd only have y's and z's in the top two. And we could also do elimination. If we did elimination, which two equations would you start with? Okay, so several different choices. I think I'm going to do this one with some elimination here. And I'm going to take a look at those top two, because I notice if I just add those together as they are, I get 5x plus 5y, my z's cancel out, equals 30. And I could work with it like that, but I also notice those are all multiples of 5, so it might be kind of nice just to multiply everything by a fifth, so that I am simply dealing with x plus y equals 6. Now, so far, I have only used the top two equations with this strategy. I must also use the third in there. There's no way I'm going to get to an answer if I don't use all three of those. So now I need to put the x plus y together with the x minus 2y, except I think I'm going to multiply this one by a -1 so that my x's will cancel out there. And if I do that, I've got minus x plus 2y equals 0. So 3y is 6, which tells me that y has to be equal to 2. Then I just start substituting y equals 2 into some of those original equations to get the others. If I put 2 in for this y, I have x minus 2 times 2 equals 0, so x equals 4. And then I need to come up with z. Doesn't really matter which equation I pick at this point. I think I'll take the top one. 2's are slightly smaller than 3's. I have 2 times x, so 2 times 4, plus 2 times y, so 2 times 2, minus z is 14. So 8 plus 4 is 12, and if I subtract that from both sides, minus z is equal to 2. Is that what I meant to have there? Yeah, so z is negative 2. And then I can write that as a triple since this was a system. X is 4, y is positive 2, z is negative 2. And I could plug those in, all three of these original equations, and they would all three equal 2. So anybody with questions on that? Okay, I'd like you to grab your new problem set paper and take a look at problem number 11. And let's kind of think about strategies here as you get started. This system is a little bit different because each of these has two variables. They all have a different combination of 2. We've got x and y, then x and z, then y and z. So substitution or elimination might be a little bit trickier to do. I'm going to suggest substitution on this one. So if we do substitution, we want to look for ones where we have a 1x or a 1y or a 1z, if possible, to make life a little bit easier. I see a 1x in that second equation, and I see a 1z in the third, but it's a minus 1z. So I will suggest that you take this middle one and start with x equals 2z minus 3. So now you've used the middle equation. You've still got to use both of the other two. So you see if you can substitute that in, which you can for the top equation. For the bottom equation, there's no place to put an x. But when you put that substitution in here into the first one, you end up with just y's and z's. So then you combine that with the third equation and do either substitution or elimination, whatever you think is going to work for you, probably elimination, when you get to that one. So that way you started with the second, then you use the first. Now you're putting that result with the third equation so that you will have used all three of those. When you finish, please type your ordered triple into the chat window, but do not push enter. Wait for me to say something, and then we'll push enter and check. While you're waiting, go ahead and start some of your other homework problems. Because we've still got, I think, about 10 minutes or so here.